value start solving inequalities. When we solve an inequality, this is true with any inequality, the arrow switches if we multiply both sides, multiply or divide both sides by a negative. Anytime we work with inequalities, if we multiply or divide both sides of an equation by a negative, we switch the inequality. And with inequalities, if we remember when we solved an inequality, we had two possibilities for our answers. We got an and inequality. Negative 2 is less than x, and x is less than 5. And the graph was always between two numbers. Or we got an or inequality. X is less than negative 5 or x is greater than 10. And our graph looked like two arrows going away from each other. So we still have those two possibilities for absolute value inequalities. So we get an and or inequality at the end. And in general, we're going to solve our absolute value inequalities the same way as we did equations. We want to get the absolute value by itself on one side. I'm just going to say by itself. That's always our first step. Get the absolute value by itself on one side of the equation. So our two possibilities for our and or inequalities. When we have greater than or equal to, we get an or inequality. And a way that can help you remember is when you look at this, greater than or equal to, think great or instead of greater, great or. So when we have a greater than or equal to, we think great or. And when we have less than or equal to, we get an and inequality. And to help us remember this, we're going to think less than. Great or less than, to help us remember which is which. And just like with equations, once we get the absolute value by itself, we split it into two. And when we split our inequality into two, we're going to switch the arrow on the negative part. So we switch it into two, we split it into two parts, one positive, one negative. With absolute value inequalities, then we switch the arrow on the negative part. All right. So we're good with our general guidelines here. So like solving absolute value equations, we just have a few extra things that we need to keep track of. So I just want to go through some examples. We're going to solve absolute value of 5x minus 2 greater than or equal to 18. My first step is to get the absolute value by itself, just like before. So I'm going to add 2 to both sides. So I get the absolute value of 5x is greater than or equal to 20. Since we have greater than or equal to, I'm thinking great or. We get an or inequality. So now I'm going to split this into 2 inequalities. I'm going to say 5x is greater than or equal to 20, or 5x, and I'm going to switch the arrow on the negative part, less than or equal to negative 20. So I split it into 2 pieces, just like I did yesterday, one positive and one negative. But we've changed the arrow, we switched the arrow on the negative one. And now I solve for x. Divide by 5. And I get x greater than or equal to 4, 20 divided by 5. Or, divide by 5 here, x less than or equal to negative 4. And if I were to graph this, my graph for an or inequality, 2 thumbs pointing away from each other, there's 1, 2, 3, 4. There's 1, 2, 3, 4. That's 0. My graph would look like, since I have an equal, is that an open dot or a closed dot with equal? Closed dot with equal. And my arrows are going to go opposite directions. All right, so we start the same way that we did yesterday. Get the absolute value by itself, switch it, or sorry, split it into 2 inequalities, one positive, one negative. We just have to switch the arrow on the negative one. Yes?
If 5 was negative in that situation, when we divide by negative 5, would it go back to where it was before?
So when we divide by negative 5 here, we return this one around. And when we divide by negative 5 here, we turn that one around. So both would get changed. So yes, if you divide by a negative, you always turn the arrow around. No, divide both sides by a negative, you always turn the arrow around. That's no matter what. Okay, let's look at another one. Absolute value of 2x minus 4 is less than or equal to 16. Well, we already have the absolute value by itself. This is less than. Actually, I'm going to change this just to less than. So I'm thinking less than. So this is going to be an and inequality. Now I'm going to split this. 2x minus 4 is less than 16. And 2x minus 4, I'm going to switch this one, greater than negative 16. I switch the arrow on the negative one. And I make it an and inequality. Well, now I get x by itself. So I add 4. When I do that, I get 2x is less than 20. Divide by 2. And x is less than 10. Do the same thing here. Add 4. Now I get 2x is greater than negative 12. Divide by 2. and I get x is greater than negative 6. And what an and inequality tells us, one way to think of it is x is between negative 6 and 10. That's what an and inequality tells us. It's between these two numbers. And means between for what we do. And if I graph this on my number line, need some more spaces here. There's 10. There's negative 6. I have a less than. Is that an open dot or a closed dot when I graph this? If there's no equal. Open dot. We're going to go between 10 and negative 6. My line's a little crooked there. But it's interesting that the line that I did between the dots turned out almost the same crookedness as the number line that I drew. So if we get it, we have an or inequality. Our graph is two arrows pointing away from each other. And inequality for what we do, we get to a line between two numbers. All right, questions? Questions on those examples? Okay, let's do one. I want to do one more, just with a little more stuff going on. All right, so there's a little more stuff going on with this inequality, but we're going to treat it exactly like we've done the other ones. We want to get the absolute value by itself. So the first thing I'm going to do is add 1 to both sides. Actually, I'm going to change this 2 to a 5. Just so the numbers come out a little better. I get 5 times 2x minus 9 is greater than 25. I want to get rid of this 5, so I'm going to divide both sides by 5. Those cancel now. And I get the absolute value of 2x minus 9 is greater than 5. Now I have my absolute value by itself. Is this going to be an and or an or? It's a greater or. So we get an or inequality here. Split the absolute value into 2. So I get 2x minus 9 greater than 5, or 2x minus 9 less than negative 5. I switch the inequality on the negative part. Turn the arrow around. Yes?
Does it matter which one's greater than and which one's less than?
Do you always...
Like theoretically, could you have could you just switch the negative to the positive?
No.
Why is that?
Can you switch? Can you turn this one around? Is that what you're asking?
Yeah, and
not
turn
that
the
one?
other one. So could you have the first one be less than and the second one be greater than?
No.
Why?
So let me finish this problem,
Okay.
and then I'll explain it, because I think if I explain it now, we might get a little confused. So let me explain separately. All right, so I still want to get x by itself now. So I add 9 to both sides. So I get 2x equal, or sorry, not equals, greater than 14. Divide by 2. And I get x is greater than 7. Do the same thing here. Plus 9. Add 9 to both sides. So I get 2x is less than negative 5 plus 9 is 4. Divide by 2. And I get x less than 2. And this is an OR. And if I graph this inequality, my OR inequality, there's a 2. Oops, I need to go further here. There's 7. This is greater and less. Do I use an open dot or a closed dot? Open when it's not equal. And my arrows go the opposite direction. X is less than 2. Or x is greater than 7. All right. Questions? So very much like yesterday, get the absolute value by itself. Split it into 2. Greater than or equal to, you get an and. No, sorry. Or less than or equal to, you get an and. Less than. Split it into 2 inequalities. Switch the arrow on the one that makes negative. Okay. Our homework today is a worksheet. So I'll pass that out. Let me stop this.